right on to our next event. And so for that, we have Michael joining us from Cornell, and Michael has a very special guest with him today. So we're so excited to see what you've brought us, Michael. I'll hand it over to you.
Yep. Just sharing my screen now. All right, can everyone see my screen?
Yep.
Okay. Okay, Blossom, are you ready? I think he got a little tired from all the dancing. He wasn't expecting to exercise that much right before presenting. But anyways, hello everyone. My name is Michael Suguitan. I am a PhD student in human-robot interaction at Cornell. I'm currently in my 4th year, and my main project has been my robot Blossom. So I want to talk a little bit about robotics in general. So usually when people think of robots, they think of the robots that you see in movies like Eve from WALL-E and such. So if you look up robots that are existing today, like real physical robots, this is kind of what you get when you just look at the first page of Google results. And one thing that I think you'll notice is that all of these robots look very, for lack of a better term, robotic-like. So they all have these rigid plastic or metal bodies, and they have LEDs for eyes, and they look super futuristic and everything. And they, I find that even though some of them have very cute faces on their screens and they have really bright illuminated eyes, I think that we could do better in terms of making robots more friendly and something that people want to interact with, which is the main point of our research field of human-robot interaction. So on the other end, there are also robots that are a lot more friendly looking and not so focused on looking so futuristic. So some examples come from Pixar movies. So I hope everyone's seen WALL-E or Big Hero 6. And some of those ideas of making robots look more friendly have translated into real research. So there's this robot called Keepon. It looks like a little duck. There's this robot called Paro. They've given this as a companion for elderly people, and also just as a form of therapy robot in general. And there's a dog-looking robot called Aibo, and there's one called Tofu, which it's kind of this really puffy. It's kind of like a fruit. When you squish it down, then it expands. It's really cute. So I also wanted to look at what goes into making a robot. So robots, they really bring together 3 main fields from engineering. So the first of those would be mechanics, so how the robot physically moves. Compared to things in computers or like computer programs or bots in computers, robots, by definition, they need to have some sort of body and physical ways of moving in the real world. And then there's also electronics. So when you have the body of the robot, how do you program that robot to start moving? So you need some sort of electronics board. This can be connected to your computer. So right now, Blossom is connected to my computer, and it's being controlled from a program right now. And that leading into the last point, programming. So when you have all these components put together, how do you program the robot to do what you want? So this can be very low level in terms of just hard code that looks very boring, but there have been so many technologies that have come out recently where anyone can get started with coding just by putting blocks together, and then they have blocks that tell you when you're trying to make something and it doesn't work out, then it'll keep you from doing that. So there are so many ways for people to get involved in programming now. Another big component of robotics is interaction. So when we build a robot, we don't build a robot just for the sake of doing it. We also want to be able to give this robot to other people and have them use it. So that's where my research ties into. So how people interact with robots, what kind of things people want robots to do, and what things robots can do for humans. So looking into Blossom, so we have those 3 main components from engineering. So mechanics, so underneath, I'll just lift up the cover a little bit. It's made completely out of wood. So we use this technique called laser cutting, where we put wood into this big, I guess, kind of like an oven, and then we use a laser to cut out the parts, and then we take those parts and snap them together, kind of like cardboard. And then we use electronics. So we use some of these small motors in Blossom. So there are 3 motors controlling its head movement, and there's 1 motor controlling the side-to-side movement. And lastly, well, the programming part was part of the electronics, but we also wanted to focus on the user experience. So how people use Blossom. So right now I've been controlling Blossom just by moving my phone. So it's kind of copying the movements. So it's sending my orientation from the phone to my computer, and then it's sending those to the motors in Blossom to tell it how to move. So here's a video of the how we build the robot. So this is one of my great undergraduate students building the robot from spare parts. And to move the head, we just have a bunch of rubber bands and strings. So we can squish down on its head, and it's a little child safe and compliant. So it's not gonna hit you and cause any damage or anything. For the electronics and programming, I already showed you, we use these small motors. They're called dynamixels. So these motors, we can tell them where to go, and they also know where they are. So that's how we can use the phone to control Blossom and tell it, okay, the motor's at this position, so record this position and then go back to it later. And then on the programming end, again, we use the computer, and we have programs in this language called Python that control how we start the robot, how the robot talks to interfaces, like if we have a web application for it, how the robot can respond to things like videos and such. And for the user experience, we've tried to bring Blossom out into the real world by having workshops and events for people to interact with Blossom. So one of these was an event at school where kids would come in and they would be able to, I would give them my phone. It was very scary because yeah, just giving little kids your phone is not the safest thing to do. But we had them control Blossom, and we had crafts for them to customize Blossom. The little holes in the crochet let us just poke new accessories into it. And we also had a workshop where we had middle schoolers come in, and they got into groups of 4 and 5, and they would do the whole process from building the wooden interior part of Blossom to customizing the covers, and then they would use their phones to program it and time it to a YouTube video. So they chose lots of videos on, I think it was Fortnite is one of the popular ones, or videos from like Marvel movies and stuff, and have Blossom move and customize to those videos. So the newest aspect of Blossom that we're using right now is something that hopefully you guys have heard about. It's called artificial intelligence. So we don't want to always be controlling these robots, right? Like this is fun. Like I like being able to move Blossom around and everything, but ideally I'd want it to be able to learn how to move on its own. So we use this thing called machine learning, which takes inputs and then uses this thing called a model and then gets outputs out from it. So if you can think back to your math classes, you can think of this as basically a function, right? So what a function does is it takes inputs, puts it into a model, the function itself, and then gets an output. So for Blossom, how we've used machine learning to give Blossom a sense of artificial intelligence is we've used movements that people make using the phone. So we went out into one of the buildings at school, and we had videos of a SpongeBob and Pikachu being happy, sad, or angry, and then we asked people to move Blossom as if it were happy, sad, or angry, like SpongeBob or Pikachu in the video. And from that, we have a lot of these inputs. And then we create a machine learning model for it. And from that, we can generate new movements that look like they were created by real people. So I have a quick demo. Let me skip over to, okay. So hopefully you can still see my screen. But basically, so all these points on the screen that you see are different movements that people created. So if I choose one point, and then I play it, so now Blossom is going to do this movement that I just chose, but then it'll eventually start moving into different movements. So it's kind of like you're teaching a pet how to move. So you give it examples, and then you let this machine learning model take over, and it'll create new movements as you give it more examples. All right, so to summarize, Blossom is a project that I've been working on in my 3 to 4 years at Cornell. we use the three major aspects of robotics engineering. So we have mechanisms, so we design it out of wood, and we have just rubber bands and strings to have it move around in this very free floaty way, so that it's not very easy to break. We use electronics and programming, so we have the motors and then the computer programs that command the motors and get Blossom to move how we want it to. And we also have the user experience. So when we've tried to put this robot out in front of people and have them give feedback on what they would like to see a robot be able to do. The main research component to this project is to use artificial intelligence to make new movements. So we're not really at the point where robots are moving autonomously yet. So we're trying to do research to get to that point. And Blossom was a robot designed to be built by anyone for anyone. So through the workshops that we've done and just how we've tried to design Blossom as this cute non-robotic robot, we wanted to make a robot that was more accessible than those robots that you see in TV and movies.
So Michael,
yep.
Can I give you a question from our audience?
Yeah, sure.
Sure, awesome. So it's an interesting question, but this attendee is saying you refer to Blossom as it, right? But with its human or animal qualities and personification, how does that affect human-robot interactions?
Right, so it's, and there's a big cultural difference to it. I think when I speak to Blossom, when I'm speaking about the engineering aspects of it, I refer to it as an it. But when I'm speaking more kind of colloquially, like if I'm talking to, say, just my friends who are not engineers, I kind of refer to him as a he. Just he's kind of scrappy and lots of times doesn't act like how I want him to act. There's been there are lots of different fields within human-robot interaction, but there are some key points to designing robots to have them have some sort of some sort of personality to them.
Yeah. Sorry, I was laughing at another question. One person said Blossom is so cute, which is true. But also, is Blossom a mouse or some other kind of animal? What is your inspiration for Blossom?
Right. So I think I usually call him a mouse, but I think the main inspiration was just so it was born out of this project. We were working with some corporation to try to create a robot that could work with children with autism spectrum disorder to show emotion. So we just thought, okay, what's the simplest platform that we can use to get expressive movement? And the main skeleton is kind of what we came up with. And we thought, it's weird if we put arms, which we've tried. We thought ears were cute, so we just put ears on. And the cool thing about the ears is we can swap them out. So as long as we have these two little holes here, then we can just pop different ears back in.
So very interchangeable. I actually have a question for you. Is this what you imagined yourself researching before you started grad school?
Yeah, this is a great question. I was actually prepping for this, but I've just always been very obsessed with robots. So I've, like ever since I was a kid, it was my dream to build robots. I got to work on building robots and working on robots in Japan for a little bit, which was like my dream for 20 years. And I liked it so much that I like robot toys so much that I decided to do a PhD in building a robot toy.
Yes, it's pretty cool. We love Blossom.
Blossom loves you too.
Oh,
I think.
Oh, I already asked that one. How long did it take you to put Blossom together? And do you think that it's possible for some of the attendees at home, whether they're in middle school or high school or wherever they are, to actually build something like Blossom at home?
Right. So getting the design down took, I think at the current stage, it took maybe 2 semesters worth, so around a year. We went through a lot of iterations. The first one was this big, heavy, fully 3D printed chunk of plastic, and then eventually the master student I was working with was just like, this is kind of dumb. Let's just use rubber bands and string, and we've kind of ran with that. So the design process took about a year, and the machine learning side is ongoing. So So in terms of the reproducibility, we've actually given this design to other researchers and just hobbyists. It's available online. I don't know if there's going to be like show notes, but we can send the link out where
Yeah, we can
have,
share that.
right. So we have the laser cut files. So you give those files to like an online laser cutting service, and they can send you the parts. And then we have all the software online, so they can put it together. We've had people send in examples of their own blossoms built just by looking at those designs.
Awesome.
So I think it would require some parental guidance, but I think it's doable.
Cool. And just a reminder before I ask the next question for everyone, these videos are going to be available on the website later, so you can always take a look at Blossom again and maybe get inspiration for your own robot at home. I have a really good question here. This one is, it's very thought-provoking. This is from Artash. I hope I said that correctly. They say, thank you, Michael, for this awesome demonstration of Blossom and talking about your work on artificial intelligence. We've been building AI robots at our home using machine learning and computer vision. Can you let us know your thoughts about the following question? Is all of your work on AI making robots more like humans, or are humans becoming more closely resembling robots?
Right, yeah, that's very great thought-provoking question. And I think it's a question I think about a lot, like how just phones, like I'm on my phone, I don't know how many hours a day and everything. And it's, and we're using these social networks that really just train us to want more likes and more engagement and like more popularity and everything. So in that way, it's not even just robots, but the artificial intelligence systems that are, and machine learning that's being used to try to get you to keep going back to their platform are kind of making us more robotic in that sense, and that we have these reward functions that we want to try to optimize, and that's really how these machine learning algorithms are created. So yeah, it is an interesting point that the gap is kind of closing between robots and humans in terms of roboticness and humanness. In terms of the humanity from the robot perspective, I think that is a big goal too. But I think one thing that we're trying to do by kind of imbuing this mechanism with intelligence is try to get people to think about what is intelligence. So if we train, in Blossom's example, we give it all these movement examples. If these movement examples are just from one person, then it's going to act like that one person thinks. But how we've tried to crowdsource it is by having this control method that anyone can pick up and get used to very quickly. So in terms of that, it's trying to diversify the range of movements and kind of show different values from different people. Mm-hmm. So yeah, and I guess in that sense, it is trying to humanize the robots by like trying to empathize with more people in some sort of way.
Yeah, absolutely. And I know, I can't remember where I saw this video of Blossom. I think that guy showed it at some point, but Blossom really can have pretty distinct emotions.
Right.
When you're watching it,
yeah,
her, him.
Yeah, it's really easy to get it's really easy to get sad. It's just looking down, basically yeah. Looking like this.
Right.
Anger is one that's been difficult just because it looks like not capable of expressing anger.
Right. I have another question. So this is something I'm wondering as well, but Lisa is asking, what do you plan on working on in the future, either with Blossom, or where do you see this work taking you?
Right, so I guess in terms of the rest of my PhD, it's still focusing on the artificial intelligence aspects, mm-hmm. But it's also, I think it was Natasha who was speaking a bit earlier about how engineering and science and STEM can also bridge art. And I think that's something that we've tried to imbue in this project, and that we tried to empower more people into getting involved with STEM, even if they're not really technologists. They can provide so many things just by being artists or being sociologists and whatnot. So I think in the future, trying to focus more on that aspect, especially for the machine learning. So I'm trying to think of ways to have the machine learning model be trained more quickly, so that it updates the preferences of particular users. In terms of, I guess, personal life goal trajectories, I definitely want to continue hopefully working on robots and creative applications of AI in general.
Awesome. Oh my gosh, so we have so many questions. I'm trying to, some of them are similar, so I'm trying to pick ones
Yes,
that'll answer multiple questions at
problem.
once. Yes, it is. Two comments that I think are important. One is from Margot. It's important that you give Blossom a pat for us and thank Blossom for the cool presentation. That's just one comment. And Sarah Cox is wondering, who crocheted Blossom?
So my advisor, Guy Hoffman, actually crocheted Blossom, and it was his first job crocheting. And since then, we've had like just volunteers make different covers, and the collaborators that we've had, they've found people to crochet covers, and none of them have come out as good as this one. It's just something about it's like beginner's luck, or I don't know, luck of the first draw or something, but it just fits so well. It's so flowy. So at the workshop that we had where the middle schoolers would build Blossom, we actually we had hot glue guns for them to like put the crafts together, and they actually hot glued directly onto the cover.
Oh no.
It's kind of scary, but we got most of it off, but there's like a few parts where it's hardened. It's like you can tell that there was glue there at some point.
It's good memories. Here's another question from Lila, and it kind of piggybacks off what I mentioned earlier about if this is, if you knew that this is what you wanted to look into during grad school. But Lila's wondering, when you were their age, let's say middle school for this question, were you interested in robots, and did you know that you wanted to do this when you were older?
Right. So I'm trying to stop Blossom. Okay. Yeah. So like what I mentioned earlier, okay, he's got a mind of its own. But yeah, so gonna geek out a lot, but I was very into Japanese robot anime since I was really 5 years old. I'm from the Philippines, and there was a big robot anime back then that was big in the 70s that I was just obsessed with, and ever since then, it's always been robots. You can't see them now, but I'm surrounded by robot toys from Japan. And I was just always, I never stopped playing with toys, which I kind of had to hide at that age. But that really informed like my approach to engineering, and just being able to pick up a screwdriver and take things apart, make modifications to it, put it back together. I'm glad that I never let anyone put me down for being into that. And I think, just like I said earlier, I've just loved robot toys so much that I tried to make my PhD on building a robot toy.
Okay. Is this your, these are both good. Okay, maybe a quick answer to this one, and then there's an important one after this. Is this your first robot, and did you teach yourself the skills that you needed, such as the programming, machine learning, etc.?
Right, so my background is mechanical engineering, and I minored in computer programming in undergrad. I love showing off this project. So this is not my first robot. You guys can still see my screen, right?
Yes. Okay,
so this is a quote unquote robot that I made for my undergraduate graduation. See if this video plays. So this is when I was graduating from mechanical engineering and computer programming. A lot of the skills I learned were just from YouTube. Coincidentally, okay, so you can see I have a motor in my tassel, and I have a switch so I can flip it without having to move it. And you see my friend there struggling. He like went too far, he overshot and had to go back and forth. So this was one of my earlier robots. But
that's
yeah,
awesome.
So I'd say almost all of the skills I used in creating this didn't come directly from class. A lot of it just came from YouTube. There's this guy named Jeremy Blum. He actually went to Cornell and did his.
Oh, Jeremy Blum.
Yes. Yeah. He taught me how to use Arduinos back when his were the only tutorials there. So there's just so much that you can learn online now. It's really
maybe we could post that link to Jeremy Blum's website after this.
Yeah. So in terms of like the machine learning aspects, I just learned that from online tutorials. I never took a class in it. Well, I did, but not the specific kind of machine learning now. Design is mechanical engineering. So.
And one last question before I kind of close up. what are the barriers that you faced in getting where you are today? Were there any courses that were helpful for you? But I think this question could be relevant to a lot of different aspects of your journey.
Right. So I think, I guess personality-wise, I'm fairly impatient. So it's just I want to see results quickly. So and that's something that you can't really do when you're building hardware, and also the machine learning aspect, because the machine learning takes a long time to do. So I guess a personal barrier is just learning how to be patient with engineering and science in general. It's often a slow process. Sometimes you'll just be extremely frustrated and won't see results for a while, but eventually they will come. If it's not good, then it's not the end.
Yeah.
I can't say that I faced any major adversities throughout. Like, I mean, I never had anyone putting me down for doing engineering. Maybe there are some people who are questioning, like, oh, why would we need robots when there are like other like social problems that we could be solving. But I think a lot of the skill sets that we develop in engineering are transferable to other aspects of life. So like in this machine learning example, like I said, if we just have it trained on one person's views, then the robot and the systems are going to express those views. But then as machine learning practitioners and data scientists, we have to learn to take in the perspectives of like many other people and be aware of the biases in our systems.
Mm-hmm. Yeah, absolutely. And so I think this is a good way to oh man, so many good questions, guys. Okay, don't worry. I will record all these questions and we will hand them off to Michael, and hopefully he'll be able to answer them offline. But I think that this one from Artash, and also those last two questions were from Katie and Trisha. So thank you for those awesome questions. And Artash is wondering if you have a Twitter account. It sounds like this is the attendee who is already involved in some kind of machine learning and making robots. So they're wondering if you have a Twitter account. I'm sure that extends to maybe Instagram or other things. They would love to learn more about your work.
Right.
So do you have any kind of...
I do not have a Twitter account. My social media is, it's more artistic. It's not really robot related, but you can check out our website. It's just hrc2.io. Yeah, and here you can see our projects. So I'm sure, Maura, you'll be able to send these out.
Yes, we can send that out for sure.
Yeah, so we have, well, there's Blossom here. There's this one project that was related to your work. It was a soft robot that could change texture. Like it had goosebumps or it had pokey spikes.
Oh, sweet. I haven't seen that yet. I'll have to look at this myself.
Yeah, so these are where our projects live. In terms of new projects, I mean, most of my engineering batteries are spent on working on research. So Blossom is really the main thing I've been working on for now. But yeah, I mean, there's this website. I think our contact info is on here. So if anyone wants to reach out even more, they should be able to get in touch through here.
Awesome. Cool. Well, I think we got most of these questions, which is awesome. But again, we will answer these offline. And I know Michael is going to be more than happy to give you guys some really cool links and resources online, and make sure that you check out the website later. If you missed the beginning portion of Michael's talk demo, you can always go to our website and we will be sharing these videos later too. So yeah. Thanks, Michael.
All right, thanks guys. Bye.
Can you have Michael or Blossom give us one last, perfect. One last shake.
Just trying to stretch now.
That's a good thing to do when you've been sitting at the computer all day.
Right. Yeah, reminder to get up and stretch.
Yeah. Awesome. Well, thank you, Blossom, and thank you, Mike.